Hello, my name is Muhamad Hafizul Saifuldin bin Jalaluddin. My ID is 1810912266. Today I want to present about my project, that is analysis of three-phase Y connected generator. So first I want to present the introduction. As an electrical engineer, we are given a task to investigate or analyze an electrical system that consists of a three-phase Y-connected generator, transmission loss, and a load with acceptance power factor lagging, according to Electrical Supply Application Handbook version 3. In our country, the Standard Local Electricity Supply Authority (TMB). The three-phase electrical power is a common method of alternating current electrical power generation, transmission, and distribution. It also one of the common system used worldwide to transfer power. Based on the latest electricity supply application handbook that provided by the TMB, the system consists of three-phase Y-connected generator, transmission loss, and a load with acceptance power factor lagging 0.99 according to supply application handbook for voltage level 33 kV and above. The frequency of the load supply from the three-phase Y-connected generator at line voltage is 50 Hz, which is Malaysian standard. We need to evaluate the parameters of the electrical system in the context of transmission and load impedance, current, voltage, and acceptance voltage drop based on BS 7671 or Malaysian Authority standard. Other than that, we also need to evaluate and analyze the active power absorbed by the loads by using the 2 watt meter method and the conventional measuring method. So we require to use PSIM for our simulation. So we go to objectives. The objective of this project is to investigate the three-phase Y-connected generator to make sure students know about the Malaysian standard electricity supply, and then the objective is to study and evaluate the active power absorbed by the loads by using 2 watt meter method and the conventional measuring method. So we go to methodology. So I have do flowchart and procedure that used for this project flow. So this is a flowchart. So according to flowchart for the flow, first project task, and then we go to calculate the parameter and construct the Y circuit, and then we draw a simulation on PSIM, so we can get the value as similar with the calculation. So calculate the simulation result and compress them, discuss the result obtained, clarify the operating procedure, and conclude this project. So in this task, students are randomly assigned to the value of line voltage. The value of V line to line that assigned for me is 33 kV. By using this value, we managed to calculate the value of V phase. Here are the formula that we use for V phase. So the formula is V phase equals to V line to line over square root 3. So the value of transmission loss and the value of load was determined by using student metric number itself. For an example of my metric number which is 1810912266, the value of transmission loss and load is so load transmission is 66 plus J12 ohm, and then load is 81 plus J9 ohm. This is my drawing simulation in PSIM. So from that value we can obtain the circuit. We need to find the percentage V drop. So we're using the formula V drop V supply minus V load over V supply times 100. This is using for calculation. So we will calculate the value total power that delivered to the load by using conventional method and 2 watt meter. And then this is the procedure that I do to do a simulation and the calculation. Okay, and then part 4, we go to result and calculation and simulation. Firstly, I will show the calculation. So the current calculation have 3 because it has IAN, IBN, ICN. So this is IAN calculation, and the final answer 128.29, angle negative 8.13 ampere. So we go to IBN. The final calculation is also same because the current will same, but the angle will be not same. So the angle is negative 128.13 ampere, and ICN, the final answer is 128.29, angle 118.87. And then we go to the active power absorbed by load using 2 wattmeter method. So in power 1, the final answer I get is 2.419 megawatt, and power 2 I get 1.509 megawatt. So the total power I've been sum up and get the final answer 3.928 megawatt. So for the conventional method, the real power consumed by the load is by using this formula: P load 3 times V phase line times I phase line cos theta. So the final answer is 3.99 times power of 6 watt. So this is my simulation result that I do in my PSIM. So the power, so after that we will find the power factor. So this is power factor, and then I get the final answer is 0.99 lagging. So to find the voltage drop in each load, because it is 3 phase, so it have 3 voltage. So the voltage 1 I get the final answer is 10.455, angle negative 1.79. It's also the same because it's 3 phase, so the voltage is same, but the angle is not same. So second voltage load I get 10.455, angle negative 1 to 1.79 kilovolt. Voltage 3 I get 10.455, angle 118.31 kilovolt. And then after we get all the voltage load total, so we can find the total voltage drop calculation, V drop. This is the formula: V drop, V supply minus V load over V supply times 100. And then after we sum up and calculate all, we get the final answer is 45.12%. So this is the table that I put in all my data, so it's easy to read. So this is my calculation, and then we will go to the PSIM and the simulation result. So this is my PSIM. So I have construct a circuit Y connected. They have 3 phase because 3 supply because it's 3 phase. So I have 3 supply, 2 ammeter, 2 voltmeter, 6 resistor, 6 inductor, and then 3 earthing. So all of this value I have put the value, and then after that I do a simulation. So this is my simulation. So this is I3, I4. This is the wave of the I3, and then this is I4 wave, and V voltage 7 and voltage 8. So this is my result in my simulation, I3, and then this is result is I4, and the result V7 is its result, and V8, and this all this is result. So that's only for my simulation and the calculation. So we go to discussion. So in my discussion, from this simulation and calculation, I have compared the value of power, current, voltage, and power factor. The calculate current value is the same as the simulation value. First, the active power absorbed calculation that indicates different value between the measurement and the simulation using 2 power method. The total active power percent error is 81.9%, total different. The calculation and simulation of power factor is 0.99 from the calculation and 0.92 from the simulation. So this is the value is almost the same, but because it's a simulation, so not same at all lah. So from the The voltage drop percentage is 45.12%, not the 45, right? Not the same or any authority standard of nation. It also reveals some of the value of in the same that is the same as the calculation done by reference to the lecture note and journal. So lastly, we will go to conclusion. As an electrical engineer, the electrical device function the construct needs to be linked to the part 3 phase of the Y generator. The current and voltage line for simulation value is the same as the measurement. The power consuming value, however, is different between measuring and simulating. The loss value of the load transmission more to the inductor, which is why the angle of this step is still lagging. The frequency used for the simulation generator is 50 Hz. It's the same with the electrical supply application handbook. The voltage drop must not be less than or any measure authority standard. Use the 2 wattmeter and conventional measuring method. The active power absorbed at load was measured and analyzed. Last but not least, the machine worked completely without error. So that's all from my presentation. Thank you.